Hello, everybody. So yeah, help me, it's legacy. Probably something that everyone's said at some point in their lives, in their career. So I basically started reading, and I'm still reading, this book here, Working Effectively with Legacy Code by Michael C. Feathers. Highly recommend it. It's awesome. I actually had a rumor that Google require all their new employees to read this before they're allowed to touch any code, which is quite cool. Maybe something we should think about. I don't know. I just wanted to share it, really. So yeah, most of the talk, in fact, the whole talk is based on the book, so I can't really take any credit for much here. I know I've felt that before. I've probably had many a meeting where we talked about legacy code base or the code base that is hard to change, and we haven't got time to write tests, or we haven't got time to fix it. So that's why I started reading this book, because I wanted to feel like this less and have less of those conversations. The book it has this idea of a algorithm for handling and changing or approaching how to change legacy code. And it is a layer on top of TDD, essentially. And the algorithm is based around finding the change points in legacy code and finding the test points, because ultimately what you want to do is, if you come across some legacy code that isn't testable or isn't tested yet, the idea in the book is to get it under test first, so you can make some nice safe changes using TDD. So you find your test points, and then you identify any dependencies that are making things hard. And inevitably, in every piece of legacy code I've ever come across, there's usually a horrible dependency somewhere deep down somewhere. Or there's 100 in the constructor of something, and you've got to create them all. So trying to break those down so that you can then write a test around the thing that you need to change. So we're not actually making a change yet. We're just trying to bring the area of code that you want to change under test, so that you can then make some new changes, get passing tests, refactor them, and do that cycle. So that's what it's all about. Yeah, so as I said, the hardest thing is trying to break down dependencies. And usually when we talk about trying to test code, we're talking about needing to sense some sort of outcome given some sort of controlled input. So it's predictable and repeatable. And many dependencies make this very hard. So the trick is removing the awkward uncle from the party. Getting it under your control, trying to force him to eat the food that you've prepared and not chuck it away and walk out. Okay, so I'm going to quickly go through a really basic example of some super simple, but legacy, because it's not tested at this point, code, and show you. So this is kind of the first thing that the book talks about, or one of the first examples, about how to break a dependency in a class that's hidden away. So this is a sales class. This is and it's just got a scan method, as you can see. Oh, I can use this. Cool. And it's got a scan method. It gets a price from a barcode, and then it has a display. So maybe it's a hand scanner and it's got a display on it, and it shows a price, and that's it. But this is a hidden dependency, because where does the display come from? Nobody knows. Try and create one of these sales classes, and it throws some exceptions because it doesn't have a display. We're not sure how to create it. So we need to break that dependency, get some control over it. So one approach would be to create a constructor here, where it takes a display object and it sets something inside the class, maybe a private variable or something, and then we use that injected display instance in here. So now we can fake it because we're injecting it, okay? Which is quite cool, because we can do things with it that we couldn't before. We've got access to this call, essentially, potentially. This is a fake display. So we extend the display class, and it looks pretty strange because it doesn't do anything, but we don't care about the display, what it does, because our change isn't around how it shows a price. We just want to check that it still calls show price when we call this method scan. So all we do is we override show price, take a price in, and capture it in here, okay? And that's for reuse later, for reference later, which you'll see here. So we now use that in the test, and this is great because now we can inject a fake display, and we can call scan, and now we can sense what the price was that we gave display because we captured it before, right there, but we couldn't before. And then we can assert, make it a simple assertion. So it's really, really simple. It's not rocket science. Legacy code won't be like this. It'll be a lot harder, obviously. But this is just a really simple example of breaking a dependency in a very simple way. And you can extend this a little bit. So one of the solid principles is to rely on abstractions rather than concrete implementations, which these guys are here. That's an abstraction from the display, which I've just called displayable as an interface in this case. And these guys here implement that interface. Sail is dependent on that interface. It's not dependent on the concrete implementations down here, the low-level detail. Okay, the higher-level detail up here, the abstraction. So that is cool because now we can fully mock this displayable thing. And, well, I kind of preempted my slide. But now we can inject a displayable thing, and it always has a show price, so we can fully mock this now. We don't just have to create a fake display, and we're also not dependent on concrete implementations anymore. So that's just kind of an extension of what we did, and you can keep working on that. The beauty is this first thing gets the code under test. I know it's very simple, but it gets under test. So now you can start thinking, all right, how do I refactor it? So you kind of enter the tail end of the TDD cycle. So you've got something under test, and you can start refactoring, reworking things, expanding your improvement of the code to make it even more testable. Oh, done that one. But this example here does have some drawbacks. So ultimately about finding the right balance. So we have changed the constructor, or given a new constructor to the sail class, which means that all usages of or implementations of sail now have to deal with this injected displayable thing. So okay, we have to go through the code now and make all those alterations. So you can imagine if this proliferated across the whole code base and it was a big project, maybe other projects depending on the library. Okay, you can see that being quite an impacting change potentially. So as I said, it's all about finding the right balance. So you try and isolate the changes that you make to get things under test in the smallest scope possible so that you can then begin to do TDD to make your new changes. That was really fast, bloody hell. Okay, so this is the tail end now. So I didn't think I'd have much time to talk about these, but other patterns and things that the book talks about, I mean, that was just the tip of the iceberg. Things like sprout method or sprout class, that's where you want to make a change, but you're under a lot of pressure and you haven't really got enough time to get the whole class under test. So you isolate the thing in the class or the method in the class that you want to change. You extract it, sprout it, and create a test for that. You don't change the thing that you extracted it from. You also don't change the behavior because you're not changing anything. You're just extracting the code from the class or the method that you want to test, and then you change it and do TDD on that. Wrap method or wrap class are kind of similar, like the decorator pattern kind of style stuff. So you enhance behavior, you create layers of behavior. So you might say have a class that has a method that is scan, so the one we had, and you need to scan and then do some of the behavior like scan and send receipt. Okay, but at the moment scan just does what we saw. Instead of changing or adding the behavior to the scan method, you can create another method that does the receipt stuff and then move the logic out of scan into another one that says something else like, I don't know, simple scan or something, and keep the scan method. So you keep the original and you just wrap the two inside it. So that's the wrap method. So you call the new one after the old one. And similar, I won't go into decorate pattern because that's slightly more complex, but you're basically layering behavior to give you extra leverage on the thing you're trying to test. And there's tons more in this book. It's really cool. I really recommend reading it. It's helped me out a lot, and I'm still reading it. There's still loads in there. That's it. Any questions? Silence.
What's your next talk?
Depends on the questions. Yes. Sorry? Yeah, all the time. all the time. So a couple of days ago, actually, we wrote a class that spied on. In fact, it was exactly the same as that example, pretty much. Just it spied on a set of some request, a request object that you pumped into a HTTP client. We didn't have access to the parameters that were inside that, so we wrote a wrapper that just had an instance of the original class in itself. It also implemented the same interface of the class, so it had the same method signatures in it, and you just called the original inside it, but you also captured the request at the same time in an accessible variable inside the class, which is quite useful. I'll do that. I don't know. I mean, I'm not talking about production code going into a release and out into the real world. This is to test production code. So I'm not creating classes for the release product. But it's a good question, and I don't know the answer. New talk. Anyone else? Has anyone read the book? Wow, yeah, okay.
It's on my list.
Cool.
Secret Santa.
Oh, yeah.
Everyone's together.
All right, if that's it then. Thanks. Cheers.